Yes, ma'am, you're audible, ma'am.
Okay. So, how was your experience yesterday? Were you able to understand?
Yes, ma'am.
So today, before any comments?
No, ma'am. Actually, not yet ready to make any comments, ma'am. We have to go through and then tell.
Okay. So today, before starting the class, what I thought is that I will tell you what are the steps involved in a machine learning project. So what are the steps you have to follow? So based on that, you can choose your project and you can start working on those lines. So let's start with the steps involved in the machine learning project. So any project will follow the same steps. So the problem can be different, but the steps are almost the same. One or two steps will be varied, but most formally, this is the framework for any machine learning project. So the first thing is that not only for machine learning project, for any research project, this is the thing, but for whatever steps I'm going to write today is tailored for machine learning projects. So the first thing is we have to have a proper problem definition. So you have to clearly define the problem and its objectives. So you have to identify what problem you want to work. You have to identify whether it is a classification problem, regression problem, or segmentation problem, or clustering, or any other ML task. So identify whether I'm writing this up so that you can use it while you are doing your project.
I can't see your screen, ma'am.
You can't see my screen for others.
Ma'am, it's visible, ma'am.
So sorry.
Visible for me also.
Dr. Shanti, were you able to see my screen now? Dr. Shanti?
No, I'm not able to see your screen, sir.
Uh, maybe can you leave the
We are
meeting and
able to
join again?
we are
Yeah,
able to
just
see,
I'll
ma'am.
join again.
Maybe internet lag would have caused.
From the beginning. Okay, let me. I'll disconnect and call again. Yeah, sorry to interrupt.
Okay, ma'am, no problem. So you have to identify whether it is a classification problem, regression problem, segmentation problem, or a clustering or any other machine learning task which you want to do. And then you need to understand the domain which you are working. So for example, in most of you are from medical background, so you know what are the different types of data which is available in the in medical domain. So you have to first choose which kind of data you're going to work. So are you going to work with imaging data? So imaging data, in sense, you can use any X-rays, CT, MRI, ultrasound, or PET, or mammogram. You can use any of those things. So based on that, you have to choose your ML algorithm. The second type is electronic health records. Or tabular data. You can say it as tabular data. So it can be demographics, lab results, or vital signs like blood pressure, temperature, or medications or treatment plan or even disease codes and diagnosis. So most of the people who are working in informatics can choose this kind of data. So examples are so this is one more type of data which you can choose for your project. And the third is genomic or molecular data. So examples for this are gene expression data, if you have access to any lab or any public repository, you can choose this kind of data. DNA sequencing, proteomics, or metabolomics. So these are all high dimensional data. You can use any one of those things for this one. And the next is histopathology or cytology data. So you can take any breast, lung, or any other cancer stained slides. Immunohistochemistry, receptor status assessment such as ERPR, HER2, or immunohistochemistry data, blood smears, and cytology data. Dr. Shanti, were you able to see the slide now?
Yes, I'm able to see. Thank you.
Okay, yeah. So these kind of data you can choose. And the other type of data is time series data. Example for time series, it is recorded over time, like it is in ICU monitoring or any wearable device data. So if it is ICU monitoring, you can take ECG data, EEG data, or continuous glucose monitoring data. So it is, you can take it from ICUs also, other kind of ICU data or wearable data. And then you can also take it from clinical notes or other text reports. So any radiology or pathology and pathology reports, or doctor's notes or prescriptions. From that also you can do some projects. Next is some watches. If you're collecting some sports watches, if you're collecting data or any sensory data from wearables can be used. So wearables which measures heart rate, SpO2 level, activity level, like how many steps per day. So those kind of data, continuous blood pressure. and ECG data from watches or remote patient monitoring data. So you can choose any one of these things. So these are some examples. This is not limited to this. So you can choose any one of the data. So define your problem and objectives correctly. Choose the data which you want, and then choose what type of problem you want to do with that one. Understand your domain clearly. So that is the first step involved. And the second step is data preparation. So after getting the data, you have to prepare the data for your model. So what you have to do is that we have one class we have dedicated for data collection and preparation. So the second step involved is data collection. After knowing your data, you have to collect your data. So you can collect your data from your own hospitals, or if your hospital does not have a data readily available, then you can choose it from public repositories, internet, or even experiments from lab. You can take the data. So since most of your people are working in hospitals, you can take your own data, but ensure your data has diversity and representativeness. So the next step in after collecting the data, when you are collecting, you have to collect with the ground truth. So then the next step is data processing. Data processing and data cleaning. So in data processing and cleaning, what are the things you will do? That this is the most important step. Even machine learning models you can get, but data preparation and processing is the most, what to say, the majority of your work will be in this one. So what you have to do after getting your data is that you have to handle missing values. Remove duplicates. And correct for any inconsistencies. So we saw a few of the techniques yesterday. So you can use that one or some other techniques which is relevant to your data. And the next thing which you have to do is that you have to normalize and standardize the data so that everything is in the one range. So if it's a numerical data, you have to normalize it and you have to standardize the data. Sometimes you need to scale your data also. So based on your data, you have to choose a method and do it. So if it is a categorical data, you have to convert into numerical format. If your machine learning model needs numerical format, then you need to convert your categorical data into numerical format. So one example for doing this is one-hot encoding, which we have seen in the class. And then suppose if you have very less number of images, then you have to do data augmentation. Data augmentation is increasing the number of data with a limited set of data. So for that, you can do rotation, flipping, which we have seen yesterday. So you have to perform data augmentation if it is needed. Suppose if you're, so this is with the data preparation. Suppose if you are doing exploratory data analysis, so what you need to do is that you have to visualize the data distributions and correlations. So visualization of data is very important. Whether it is imaging data or tabular data, any kind of data you are using, you have to visualize the data distribution and correlations. And then you have to identify if any patterns are present in the data or any biases or outliers are present. So visualization can help you identify these things. And then you can use a statistical method to understand the data characterization. So far we have been seeing machine learning. So in machine learning, there is an important concept called if you're using machine learning algorithms, then you have to do feature engineering. Feature engineering is selection of features and then extraction of features and then selection of features. So this is called feature engineering. And then you have to select features. For that, you can use techniques like TCA and so on. After doing feature selection and feature extraction and feature selection, the next step is you have to choose an appropriate model. So model selection is important. So whether first you have to decide whether you are going to use machine learning or deep learning. So after choosing whether machine learning or deep learning, you have to choose an appropriate model. Based on your, again, with the selection of the model is based on your data. Suppose if you are choosing imaging data, then CNN would be more appropriate. If you are using any electronic health record data, then a normal machine learning model will be sufficient. So you have to choose an appropriate data. So sorry, you have to choose an appropriate model for the data. So this is based on, so how will you choose your model? It is based on the data size and complexity. So based on the data, for small data, there are certain models. For big data, there are certain models. And also based on your data type. So if you are using CSV file, then simple ML algorithm would be sufficient. If you are using images, then CNN model will be better. So based on the data type and data size, you have to choose your appropriate model. So after selecting the model, you have to train your model. So for model training, the first thing is that you have to split the data into training, validation, and test set. So you can train the model using a proper optimization techniques. We'll teach you certain optimization techniques in the upcoming classes. So you can train the model. And then we have to apply optimization techniques, regularization techniques, which we will be teaching in the upcoming classes. So after training the model, you have to evaluate your model. So for evaluation, there are a number of metrics available. We have seen few of those metrics. We'll be seeing a few other metrics in the upcoming classes. So what are the metrics we have seen for model evaluation? Like, so we can use technique measurements like accuracy, precision, recall, F1 score. So we can use metrics like this. This is all for classification models. So if you are using any regression model for continuous variable, then you can use root mean square error, MAE, all those things for regression models. Also, you can, for model evaluation, you can perform cross validation. Cross validation and hyperparameter tuning. So this is the basic steps involved in the machine learning. So I expect you to complete till 8th step. But the whole machine learning cycle, in the next step involved is model deployment. So once the model is ready and evaluated, we have to deploy it in the real-time setting. So you can deploy it as an API model or a web-based app, or you have to integrate it with other systems. So once it is done, model deployment will also include optimizing for the interference speed. So we have to optimize it so that the inference speed is good. And also it is resource efficient. For developing, we don't see if it is resource efficient or not, but while deploying, we will see if it is efficient. So the next step is, after model deployment, what we will do is that we will continuously monitor it for, and also we will maintain the system. And also we need to, as per time, we have to update the model. So we cannot use the same model for a long time. We need to keep updating it, because the data might change or the model will get outdated with the data. So we have to keep updating with it. So suppose, and another important step when we are using medical data is that we have to we have to carry out certain steps based on the data. So if you are using patient information, that make sure that the data is anonymized. So if you have already sought the ethical approval, then you don't have to anonymize it. But if you are using it in your project, make sure that the patient information is anonymized. And so in medical domain data, so after monitoring and maintenance, we will also look for clinical validation. So when you deploy the model, before you deploy the model, we will sort for clinical validation. That is also involved. But these are the steps, whatever steps I have written, it is the steps for the general machine learning project. And this is applicable even for medical data. So any questions so far? Do you have any questions? So if you have any questions regarding the project or selection of the project, you can ask in the group or you can ask to me. So, and also I can ask Dr. Akila to help you in the projects. So any questions? So there are 10 steps in it. So when you are choosing, your first thing is select your problem and make sure you define a achievable objective within 2 months. You have got 2 months for it. So select a problem which is doable within 2 months. And or else if you can select a big project, suppose you can use your own PhD project and then do a part of it here. So, and then if you have to choose a separate data for this project, then choose any one of the medical data as defined here, and then clean the data, use certain pre-processing techniques. You can use MATLAB. If you're familiar with Python, you can use Python also. So do the data processing. And if you are doing exploratory data analysis, but I suggest for any analysis, any data analysis, you have to visualize the data and identify the patterns and correlations between them, and then extract the features and use feature selection for feeding into the model. And this is the major step. So I think you might need help in this model selection. All other things you can do it by yourself. For model selection, you can seek the help of either Dr. Akila or me. So you have to choose whether you are going to use machine learning or deep learning. From today's class, we will start deep learning. So far we have been seeing machine learning models. So from today we will start looking into deep learning. So you can choose either of these two techniques, whether machine learning or deep learning. And after selecting the model, you have to train the model. For training the model, you have to divide the data into training, validation, and test set, and then train the model. And for training the model, we have seen how to train the yesterday's class. We have seen how we have trained the machine learning models. We will in future we will have one tutorial for deep learning. So we will also learn how to train the deep learning model. It will be dealt in the class also, and then we have to evaluate the performance of the model using performance metrics. So there are unique performance metrics for this one. So whatever I have written is for classification. For segmentation, there is a uh, something called die score, hash of distance. So these are all used for segmentation. Oh, so till this one, it is expected for your project, but in real-time machine learning projects, so they use a model deployment, and monitoring and maintenance is also used after deployment of the model. Monitoring and maintenance is also used. And the most important point is that anonymize your, if you're using your hospital data, please anonymize it and use it in your project. Is it clear? So if you have no questions, then we will go to the next class. So what we did in the last class, anyone can recollect?
Yes, ma'am.
Yeah.
Ma'am, we started with nail bias and what it is. Then we went back to little bit Bayes theorem, how nail Bayes works. Then we discussed about different types of class, this KNN, SVM, decision trees and nail Bayes, which trains quickly, which predicts quickly, pros and cons we discussed, ma'am.
And then?
Then we saw about ensembles, voting and bagging, ma'am.
So there are two types of ensembles. One is bagging and the other one is boosting. So in this class, we will see boosting, and then if time permits, we will start with the deep learning technique. So boosting is one type of ensemble. So it is not only popular. So bagging, we saw that, and also we saw random forest. So we saw that bagging is used, decision trees are used in the bagging. So in boosting also, we will use decision trees, but it is not only applicable to decision trees, it is applicable to any kind of learning systems. So we will see binary classifiers here. So boosting lets us to combine large number of small, fast, inaccurate learners into a single accurate learner. So it uses small. So this is the concept of boosting. So bagging, it is also similar, where ensemble means a large collection of data. So sorry, large collection of learners. So here we will use many learners, many weak learners combined into a one single strong learner. So for this one, we will use the examples of 2D data and two category data. So suppose if your data contains samples of only two categories, and you have a a random binary categorizer. So what is a random binary categorizer? So suppose it will pick one of the two categories. If it has only two categories, it will assign one of those two categories arbitrarily to the sample. So suppose if you have A and B as your category, it will randomly choose either A or B and then assign it as a category. So it is 50% chance to A and 50% chance to B. So we have 50-50 chance of each of the sample being correctly labeled. So this type of labeling is called as random labeling. So the chances of getting a right answer is totally dependent on chance. So let's take one example. Suppose you have a 2-category data like this. So if you want to divide this data into two, what is the best thing to do? Any idea?
Circles into one group and squares into another group.
Yeah. So you have a straight line now. So how will you divide it? So you have a straight line. So you can place the straight line. Suppose you have a straight line. So you can place the straight line like this, straight line like this, like this.
Horizontally.
So the best fit is
Horizontally.
horizontally. Suppose if I draw like this and like this. So this is also possible, right? So the best fit comes. So this is the strongest learner because it splits the data into two different data. This one. This is a useless classifier because it is only by chance we can get the right category. So horizontal thing is the best split which we will get, but this is a terrible classifier or a learner. But if you look at this one, this is slightly better than this one. Why it is slightly better? It is also a useless classifier. So if you look at this one, this is also a useless classifier, but it is slightly better than this. Why it is slightly better than this? Because it has a slight tilt over this one so that the majority of them, it is better than chance. So this is called as a weak classifier or a weak learner. So a strong classifier is one which completely separates the two classes. A useless or a terrible classifier is one, it happens only through a chance. Only through chance we can get the best answer. And the third one is the weak classifier or a weak learner. It is better than a chance. Here the slight tilt is making it slightly bit accurate. So it is little bit better than the chance. So what we will do in boosting is that, so we will choose the most commonly used decision, weak classifier. The most, commonly used weak classifier is a decision tree. So what type of decision tree we will choose is that we will choose one parent with two children. So this kind of decision tree is called as decision stump. So it has only one test. So it has only one test to be addressed, and then based on that one test, it will send the data into two nodes. So it has the whole tree. If you look at it, the whole tree is made up of only one parent or one root node and with its 2 children. So this small decision tree is usually called as decision stump. So what we will do here is that we will combine lot of decision stumps together, not just one, lot of decision stumps. This is also a weak classifier. So we will combine several weak classifiers into one strong classifier or strong learner. So it almost does, if you look at this decision stump, it is better than a useless classifier. Like how we saw, it is a weak learner, it is better than the chance. So similarly, this decision stump is better than selecting something randomly. So the boosting, what does boosting does is that the boosting will combine several weak classifiers into an ensemble that will act as a strong classifier or a strong learner. Why we are combining several weak classifiers is that because they are faster. A complex, strong learner will take a lot of time, whereas the weak classifiers will take very less time, so it is faster to compute. So instead of using one strong classifier, we will use several weak classifiers so that they are faster, but at the same time it will produce the accuracy similar to a one strong classifier. So that is the reason we are going for boosting. So let's take one example. So here we have a 2D data and 2 category data. Suppose if I want to split this one into, they are linearly separable, but however, one single line cannot linearly separate this data. Suppose if I want to split this data and I have a line like this, let this line be a classifier called A. So if you look at here, it on the upper side, it is classifying appropriately. Maybe it has a better thing. But if you look at all the circles are there in one side and the rest of the things are in the other side. So in the upper side, it is classifying correctly. But in the lower region, if you look at it, the classification is not that perfect. So though we have both the classes here we have majority of circles, but on the lower side, it is not perfect. It has some squares. So it is a weak classifier. It is a weak classifier. So this arrow indicates positive side of A. So what we can do is that instead of using one weak classifier, boosting says we need to use multiple classifiers. So what we can do, we can add some more lines. So suppose if I'm adding some more lines like this. So let this classifier be B. Let this classifier be C. So this is the positive side of B. This is the positive side of C. So if you look at here, we have 3 classifiers and how many regions? 1, 2, 3, 4, 5, 6. So we have got 6 regions. So maybe I can draw this classifier a little better. So if you look at it, so we have got seven regions. So this is square. So 3 regions of circles and 4 regions of squares we have got. So So what we are doing here, if you look at the regions, their regions are properly classified. So we have multiple weak classifiers and the regions are properly classified based on their categories. So this is one way of splitting. This is one way of boosting. So what we can do is that we can assign some regions for this one. So let me draw this in a proper way. So we have three classifiers. So let this be A, let this be B, let this be C. So what we can do is that every positive region we can mark by the categorizer name. So this is the positive side of A. So the positive side of A, I am writing all the A's. So this region is the positive side of B. So all these regions are the positive side of B. So I am writing B here, the positive region of B. So this region is a positive region of C. So I am writing C in all these regions. So we have marked each region based on the learner's name. If it is positive, we have written the region name. So now what we can do is that we can assign weights for these regions. So if A is in the positive side, it will take 1 as a value. If on the negative side, it will take the value of 0. Similarly, B will take the value of 1 in positive region. B will take the value of 0 in the negative region. Similarly, C will take the value of 1 in the positive region. C will take the value of 0 in the negative region. So now we can assign the weights and we can so for each of positive region of A, so if I put 1, so here A and B is positive, so A and C is negative, so it will have the value of 2. Here A is positive, so and B and C are negative, so it will take the value of 1. So here A, B, C, all three are positive, so 3 regions, so we write 3. So here A and C is positive, B is negative, so it will have the value of 2. So here B and C are positive, A is negative, so it will take the value of 2. Here C will take the value of 1 and here B will take the value of 0. So we have written the weighted region. So the regions each region's mark are getting some values. So now if you want to turn this into a working classifier, we have to weight it approximately. This is one way of weighting. So what we can do is that, so we have got 3 regions, A, B, C. So what I have done is that I have marked the positive regions of A, B, and C. So this is the positive region of A, this is the positive region of B, this is the positive region of C. So what I can do is that I can give weights for each of these regions because we need to have a working classifier with the right weight. So here what we have seen is that here we have assigned what to say 1 for every positive region and 0 for equal weights for all positive regions and equal weights for non-positive regions. So here what we can do is that we can assign different values. For A can take the value of 1 in the positive region, B can take the value of 1.5 and C can take the value of -2 in the positive region. So now we need to combine all these 3 and then write it. So if you combine all these 3, so what we can
Ma'am,
get, yeah.
ma'am, how do we choose the positive side, ma'am?
So if you look at here, so I have put an arrow for A. So
Okay.
this side A has 2 parts.
Okay.
So
Any side you
one
can
second.
take it as positive.
Any side you can take it as positive. So
Okay.
I have indicated the arrow mark. So this region is positive, this region is negative. So similarly for B, if you look at this region is positive, the other region is negative. So the arrow is indicating the positive region.
It doesn't have anything to do with the presence or absence of the variety of data like that.
No, nothing like that. So it is not dependent on the data. So for each classifier, there is a positive side and the negative side. So it has
Okay.
nothing to do with the data.
Okay. Thank you.
So what we can now do is that we can combine all these sum of scores. So earlier we assigned values of 1 to each learner. So those were the weights in the voting. But now, but many other values would work as well. So we wanted to see earlier we get same weights for everything. So now we are giving a different weights. So these dark regions, the shaded regions of the learner will get a weight, and the non-shaded regions will get a weight of 0 here. So the positive sides will get these weights, negative sides will get the 0 weight. So now we can combine all these things. So if you combine, so let us take this region. So this region, if you combine, here it is 1, here it is 1, here it is 1.5, here it is 0. So the answer is 1 plus 1.5 is 2, 2.5. So similarly, if you look at here, here it is 1, here it is 1.5, here it is minus 2. So 1 plus 1.5 plus minus 2 is 0.5. Next region we will take this one. Here the value is 1, here the value is 0, here the value is minus 2. So 1 minus 2 value is minus 1. Next, what we will do is that we will take the values. Here there is no value of, this is the negative side of A, this is the negative side of B, this is the positive side of C. So all this negative side will have 0 values. Here it will have minus 2. So now what we will do, we will take the values of this one. This is a negative value. Here a positive value of B. Here it's a positive value of C. So 1.5 minus 2 is minus 0.5. So the left out region is this. So here it's a negative value of A. So 0. Positive value of B 1.5. Negative value of this one. So this minus 2. So we will write here 1 minus 1.5. And this region is positive region of A. This is negative region. So it will not take any value. It will take only the values from A. The value of A is 1. So value of A is 1. So here we saw the voting has same values. Here we have seen the voting with different values. So let us look at another example to be more clear. So here also we can have multiple classifiers. So we'll have classifier A, classifier B, classifier C, classifier D. So here we have two classes. One is a circle class and the one is a square class. For two category of data, two category 2D data, we have 4 classifiers. So what we can do, we can assign, like in the previous case, we can assign weighted values for the positive side of each category. So for simplification, I am drawing like this. A region has the weight of -8. Positive side of B is this. So it has a value of 2. If you look at positive side of C, this is the positive side of C. So C is like this. So the positive side of C is this one. So I can draw C like this. C can take the value of 3. So if you look at the positive value of D, positive value of D is this way. So we can draw positive side of D like D region. D can take the value of 4. So now what we can do is that we can combine all these threes. So if you look at here, so A, this is B, this is C, this is D. So A positive is, this is all A positive. So I'm writing A. So this is B positive. So in this region, I'm writing all B. So this is C positive. In this region, I'm writing all C. This is the D positive. So I'm writing D in all these regions. So now we can take all these values and write. So here B and C are positive. What is the value of B? B is 2, C is 3. So here the value is B plus 3 is 5. Next, A, B, C is positive here. So A has a value of -8, B has a value of 2, C has a value of 3. So -8 plus 2 plus 3 is -3. So this will take the value of -3. Next, you have A and C here. So A and C is -8 plus 3 is -5. Next, you have B and C here. So B, C and D. So B is 2, 2 plus 3 plus 4 is 9. Next, you have A, B, C, D. So A is -8 plus 2 plus 3 plus 4 is 1. So this region is ACD. ACD value is -8, 2, 3. So that is -4. Next, you have the value of B and D. So B value is 2, D value is 4. So 2 plus 4 is 6. And here you have ABD. So A value is -8 plus 2 plus 4. That is equal to -2. Next, you have B and D. So B value is, sorry, you have A and D. So this is a positive region of A. So you have A and D here. So A is 4, B is A is -8, D is +4. So you have got -4. So this is how you combine and do the OT. So the beauty of boosting is that it combines several classifiers that are simple and fast, but they are lousy as a single grade classifier. But when they are combined, many single classifiers are combined, they become a very strong classifier. We can see that. So all these positive regions classify the region correctly. So if you look at here, so the positive regions are classifying it correctly. So this is the thing which we get it from understanding this voting. So the only thing is that we have to pick how many number of classifiers we want. Here we have picked for 2 categories, we have picked 4 classifiers. So what we can do is that there is a rule of thumb. So how many number of classifiers are there? We can pick that many number of how many number of categories are there? We can pick that many number of classifiers. So categorizers or classifiers can be equal to the number of classes. But here for 2 classes, we have picked 4 or 3 classifiers. In machine learning, most of the things happens by trial and error method. So we can use even cross validation to evaluate each possibility. So the boosting was made its first appearance in the part of algorithm called add a boost. So boosting is popular with decision trees. It works well with the decision stump. Decision stump is a weak classifier. But it is better than chance. So what this boosting does is that it combines several weak classifiers and then makes it into a strong classifier. So we can call the weak classifier as a hypothesis. So it combines, so what they usually tell in boosting is that they combine several weak hypotheses into a strong one. Boosting is not the only way to improve the classification algorithm, but it is usually popular because we can comprehend how it is working. So this is about boosting. So what we did in boosting is that, so boosting works well with binary classification. So it combines several, the one thing to remember in boosting is this one. This is the concept which you have to remember in boosting. It combines several fast, inaccurate learners into a single accurate learner. So we saw what is random binary classifier, and we took an example for a strong learner, a learner which works with chance or a terrible classifier, a learner which is called as a weak classifier. And then we learned what is a decision stump. So boosting combines several decision stump into one strong classifier. And we saw how to do the voting. We took some examples for that one, and then we saw how to do the voting in it. And the rule of thumb here is that the number of classifier is equal to the number of classes. But nevertheless, with the trial and error, we can have more classifiers than the number of categories. So this is what we have learned today. Any questions? So do you have any questions? So if you have any questions regarding the project or in the any steps in the involved in the project, please don't hesitate. You can ask either in the group or you can personally contact me. I'm happy to help in that one. So your final evaluation will be based on the project. So from next class onwards, so far what we have done is that we have studied the basics of machine learning. So we have seen data preparation. We have learned some techniques in machine learning. We have seen some types of classifiers. And we have also done some basics in probability. So those things we have covered so far in the basics of machine learning, because this is a prior for learning the deep learning. So from next class onwards, we will start with the deep learning techniques. So we will start from feed-forward network. Already we have seen what is meant by a neuron. So that is the foundation for deep learning techniques. So from next class onwards, we will start the deep learning techniques. So if you have any questions, please feel free to ask. If you have no questions, then we will meet in the next class. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.